Next story. Rethinking, Anthropocene, why ecologists argue for its continued relevance. In a world where human impacts on the planet are undeniable, the term Anthropocene has been a subject of debate among geologists. Despite the recent decision to not officially recognize it as a new epoch in Earth's geological timeline, ecologists and researchers argue that the term holds significant importance beyond mere stratigraphic definitions. The rejection of the proposal to establish the Anthropocene as a distinct geological epoch has sparked discussions about its broader implications. For scientists like Chris Thomas, the concept of the Anthropocene signifies the interconnectedness between humans and Earth's ecosystems. It serves as a reminder that humanity is an integral part of the planet's processes and highlights the need for collaborative efforts across various disciplines. Paleoecologist Jacqueline Gill emphasizes that the Anthropocene is a term that transcends boundaries, belonging to everyone from scientists to artists and humanities scholars. It symbolizes the era where human activities have become the dominant force shaping ecological and geological processes. Gill underlines the importance of recognizing that humans have been influencing the planet for thousands of years, and not all impacts have been negative. Yavander Mali, a biodiversity researcher, stresses the multidimensional nature of the Anthropocene, which extends beyond climate change to encompass various ways in which human activities have global planetary effects. While the term's loose usage allows for broad interpretations, Mali believes that a formal definition would provide clarity and consistency in its application. Ultimately, the Anthropocene serves as a powerful concept to broaden discussions about human impacts on the planet. By acknowledging the significant role humans play in shaping Earth's ecosystems, researchers aim to promote a deeper understanding of the complex relationships between humanity and the natural world. As the debate around the Anthropocene continues, one thing remains clear: the term holds immense value in highlighting the unprecedented extent to which human actions have transformed the planet. Source: Nature. Next story. Blues and berries, a flavorful fusion. In a vibrant world where nature often surprises us with its wonders, a recent study has unveiled the mesmerizing secret behind the deep blue color of blueberries. Contrary to popular belief, it's not a pigment that paints these berries with their iconic hue, but rather the elegant dance of nanocrystals embedded in the fruit's outer wax layer that creates this spectacular display of blues. Research conducted by Rox Middleton and a team of scientists delved into the optical properties of blueberries, uncovering a fascinating structural color mechanism at play. Through meticulous experiments and observations, they unraveled how the arrangement of nanocrystals within the epicuticular wax of blueberries interacts with light, resulting in the vivid blue we all know and love. But blueberries are not the only players in this colorful symphony. The researchers expanded their study to various fruits across different plant orders, discovering a common thread of structural coloration involving wax crystals and a dark pigmented background. From grapes to plums and junipers, nature has ingeniously employed this mechanism to produce a spectrum of hues without relying on traditional pigments. By peering through scanning electron microscopes, the team identified distinct morphologies of wax crystals, rings, rods, slabs, and tubes, each contributing to the enchanting colors observed in fruits. These findings not only shed light on the optical properties of plant epicuticular waxes but also hold promise for bioengineering applications, as demonstrated by the recreation of blueberry-like coatings on different substrates. From an evolutionary perspective, this research illuminates how nature has cleverly crafted blue fruits to attract specific frugivores sensitive to this color, all while bypassing the energy-intensive process of producing blue pigments. The study highlights the ingenuity of natural mechanisms and opens up new avenues for creating bio-inspired materials with stunning optical properties. In a world where colors paint our reality in the most unexpected ways, the blues of blueberries now reveal an intricate tale of nanocrystals and light, showcasing the artistry of nature's palette in a whole new light. As we peer into the captivating world of structural colors and their enchanting secrets, the story of blueberries serves as a reminder of the boundless creativity that thrives in the realms of science and nature. Source: Nature Physics. Nature. Next story. Unlock superior batter performance. Tips for quality improvement. In a world where baking is both an art and a science, a recent study has taken the understanding of batter quality to new heights. Picture the perfect cupcake, fluffy, moist, and beautifully colored. But have you ever wondered what goes on at a molecular level to achieve such perfection? Enter Kalayarasan Saranthian and his team, who have delved into the intricate mechanisms behind baking to uncover the secrets of batter quality. Using a multi-phase transport framework, the researchers investigated how key ingredients like water, sugar, and fat impact crucial performance metrics such as oven rise, moisture content, and color. By modeling the batter as a porous medium undergoing various transformations during baking, they were able to simulate the complex processes at play. From heat transfer to viscoelastic deformation to carbon dioxide generation, every detail was meticulously analyzed to unravel the science behind the perfect cupcake. To validate their model, the team conducted experiments with different batter compositions, measuring temperature profiles, height changes, weight variations, and color shifts during baking. Through these experiments, they uncovered fascinating insights. For instance, a high water content resulted in taller, yellow cupcakes due to increased thermal diffusivity, while a high sugar batter led to shorter, golden cupcakes from enhanced evaporation losses. Moreover, by manipulating the amount of sugar and fat in the batter, the researchers were able to control the gelatinization temperature and the transition of the batter into a foam, ultimately influencing the final texture and moisture content of the cupcakes. These findings not only shed light on the specific factors that contribute to batter quality but also pave the way for optimizing the production of other baked goods like biscuits and bread. The implications of this research extend beyond the realm of cupcakes, offering a new perspective on the role of physics in the culinary arts. By utilizing computer-aided tools and advanced modeling techniques, the baking industry could potentially revolutionize the way recipes are developed and products are manufactured. Imagine a world where every batch of cookies or loaf of bread is crafted with precision and consistency, thanks to the insights gained from studies like this. So, the next time you indulge in a sweet treat, remember the intricate dance of physics and chemistry that has gone into creating that perfect bite. From the mixing bowl to the oven, every step in the baking process is a harmonious interplay of scientific principles and culinary craftsmanship, resulting in delectable creations that delight our senses and nourish our souls. Source: Nature. Next story. Analyzing the impact of language and population on belief in COVID-19 rumors. In a world plagued by the spread of COVID-19 rumors during the pandemic, a recent study delved into the minds of young adults to uncover the influence of linguistic and demographic factors on their judgment of these rumors. With 112 participants, the study revealed intriguing insights into how individuals process and evaluate COVID-19 related statements. Participants were tasked with discerning the truthfulness of various COVID-19 rumors, based on factors like statement length, content characteristics, and demographic backgrounds. Surprisingly, the research found that participants spent more time reading longer rumors, leading to lower accuracy rates in judging their veracity. Interestingly, individuals were quicker at rejecting false rumors than accepting true ones, hinting at a cognitive bias towards skepticism. Moreover, the study uncovered a significant impact of family socioeconomic status, SES, on the accuracy of veracity judgments. Participants from higher SES families demonstrated higher accuracy rates, shedding light on the long-term effects of socioeconomic backgrounds on decision-making processes. The findings challenged conventional wisdom, showing that the length of rumors could affect accuracy rates but not response times. This nuanced understanding of how individuals process and evaluate COVID-19 rumors highlights the complexities involved in combating misinformation. As the world grapples with the infodemic surrounding COVID-19, policymakers and researchers should consider leveraging the study's insights. By tailoring corrective messages based on rumor length and addressing the influence of family SES, efforts to debunk false information can be more effective and targeted. While the study was not without limitations, such as the homogeneity of the participant group, it sets a crucial foundation for future research in understanding rumor processing and mitigation strategies. By incorporating diverse demographic variables and real-time data collection methods, future studies can further unravel the intricate dynamics of rumor evaluation. In conclusion, the study underscores the multifaceted nature of veracity judgment in the face of COVID-19 rumors. By dissecting the interplay of linguistic and demographic factors, we inch closer towards combating misinformation and safeguarding public understanding during challenging times. Source: Nature. Next story. Redefining city appeal. How COVID-19 and remote work are shaping urban living. In the wake of the COVID-19 pandemic, speculations have arisen about the future of major cities, with concerns over potential declines in urban populations. However, a recent study has shed light on the enduring appeal of city living, particularly in Tokyo, amidst the pandemic and the surge in remote working. The research conducted a randomized conjoint experiment to gauge altered residential preferences and attitudes toward residing in the Tokyo metropolis due to the pandemic. The study encompassed scenarios that included reminders of potential pandemic reoccurrence and teleworking options. The results revealed that, contrary to expectations, the allure of Tokyo remained strong, indicating a low probability of urban decline despite the challenges posed by the pandemic. The study explored how the pandemic and changes in remote working patterns could influence residential preferences, shedding light on the adaptability and resilience of large cities like Tokyo. The findings suggested that compact urban development could bolster resilience against future stressors like climate change, emphasizing the importance of sustainable urban planning practices. With a focus on Tokyo's unique circumstances during the pandemic, the research delved into the intricacies of urban living preferences and the impact of external factors on residential decisions. By examining the nuanced responses of residents to different scenarios and attributes related to housing and neighborhood choices, the study provided valuable insights for urban planners and policymakers. Despite initial concerns about urban outmigration trends, the study's findings offered a more optimistic outlook for major cities like Tokyo, highlighting the resilience and enduring appeal of urban living even in the face of global crises. The research underscored the need for data-driven insights to inform future urban development strategies and ensure sustainable and resilient cities in the post-pandemic era. As cities navigate the complexities of the pandemic and evolving workplace dynamics, understanding the evolving preferences and behaviors of urban residents is crucial for fostering vibrant and sustainable urban environments. The study's comprehensive analysis of residential preferences and the impact of external factors on city living provides a foundation for informed decision-making and proactive urban planning in Tokyo and beyond. Source: Nature. Next story. Decades of survival rates in acute myeloid leukemia across Nordic countries. In a groundbreaking study spanning over half a century, researchers have delved into the intricate world of acute myeloid leukemia, AML, survival rates across the Nordic countries. The findings, published in the esteemed Blood Cancer Journal, shed light on the evolution of AML treatment strategies and their impact on patient outcomes. Despite advancements in treating hematological malignancies, AML has historically posed a challenge, particularly for older patients. With half of AML cases occurring in individuals over 70 years old, traditional chemotherapy regimens have shown limited efficacy in this demographic. However, recent years have witnessed a paradigm shift in AML management, with the introduction of novel therapies and treatment approaches tailored to individual patient profiles. One noteworthy development is the incorporation of hematopoietic stem cell transplantation, HSCT, in treating high-risk AML patients under 70 years old. Moreover, the advent of hypomethylating agents like decitabine and azacitidine has provided a lifeline for older and frail patients who may not withstand intensive chemotherapy. These tailored interventions have not only extended survival rates but have also paved the way for personalized medicine in AML treatment. The molecular revolution in AML research has also played a pivotal role in refining risk assessments and treatment strategies. With a deeper understanding of AML's genetic underpinnings, clinicians can now tailor therapies to target specific mutations like FLT3, IDH1, and IDH2. The advent of BCL2 inhibitors like venetoclax has further expanded the treatment repertoire, offering hope to older and relapsing patients. Analyzing data from the NORDCAN database, the researchers observed a notable improvement in AML survival rates across age groups in the Nordic countries. While younger patients showed a more significant increase in survival, older cohorts also exhibited promising outcomes, especially in Sweden where active treatment protocols have been in place since 2005. A comparative analysis with US survival data revealed that the Nordic countries have made substantial strides in AML management, with survival rates consistently on the rise. Notably, the survival advantage in the Nordic countries was attributed to intensive treatment protocols, novel therapies, and enhanced supportive care measures. Despite these remarkable advancements, challenges remain, particularly concerning older patients above 80 years of age. As this demographic continues to grow, the need for tailored treatment approaches and innovative therapies becomes increasingly vital. The recent approval of venetoclax hypomethylating agent combinations holds promise for improving outcomes in older and comorbid AML patients, heralding a new era in AML treatment. In conclusion, this comprehensive study underscores the transformative impact of personalized medicine and novel therapies on AML survival rates in the Nordic countries. As the field of AML research continues to evolve, the future holds exciting possibilities for enhancing patient outcomes and narrowing the age-related survival gap in this complex hematological malignancy. Source: Nature. Next story. Unlocking photostable monomers by splitting StayGold dimer. In a groundbreaking advancement in the field of fluorescent proteins, researchers have successfully monomerized the highly photostable StayGold dimer, leading to the creation of 3 distinct monomeric variants. StayGold, known for its exceptional photostability, has long been a game-changer in live cell imaging applications. The discovery of StayGold as an obligate dimer posed challenges in various applications such as protein tagging and biosensor engineering. To address this, researchers embarked on the task of evolving monomeric variants from the dimeric StayGold. Through targeted mutagenesis and structural analysis, 3 independent research teams were able to generate monomeric variants named StayGold, StayGold E138D, and Bao-Jin. The researchers utilized sophisticated techniques, including crystal structure analysis and mutagenesis, to disrupt the dimerization interface of StayGold effectively. The resulting monomeric variants exhibited impressive qualities, with StayGold standing out as the most suitable for a wide range of applications due to its brightness, photostability, and monomeric nature. StayGold E138D and Bao-Jin also showcased unique properties, offering researchers additional options for their experiments. The comparison of these monomeric variants in standard mammalian cell lines revealed StayGold as the top performer across critical parameters. However, the suitability of fluorescent proteins can vary depending on the biological system and experimental setup, emphasizing the importance of thorough evaluation before use. The precise mechanism behind StayGold's remarkable photostability remains a subject of ongoing research. The presence of a chloride ion near the chromophore in the crystal structure hints at a potential protective role, although further investigation is required to fully understand this phenomenon. Overall, the development of monomeric StayGold variants marks a significant leap forward in biological imaging, promising new avenues for research and applications in the field. As scientists continue to explore the capabilities of these innovative probes, collaboration and data sharing within the scientific community are essential for maximizing their potential. Source: Nature Methods. Nature. Next story. Invisible spread. The stealthy nature of fungal diseases. In a world where deadly fungal diseases go undetected, the consequences are dire. Take the case of mucormycosis, commonly known as black fungus, which wreaked havoc in Indian hospitals during the COVID-19 pandemic. Thousands fell victim to this insidious infection, spreading stealthily in the lungs of patients undergoing severe steroid treatments. But India's struggle with mucormycosis is not unique. Low- and middle-income countries face a widespread shortage of diagnostic tools to detect fungal infections, leading to millions of deaths annually. Misdiagnoses are common, as fungal diseases mimic other illnesses like tuberculosis, leading to inappropriate treatments and high mortality rates among immunocompromised individuals. The World Health Organization, WHO, has flagged fungal infections as a significant global health threat, advocating for improved access to diagnostics to better assess the burden of these diseases. Efforts are underway to expand diagnostic capacities in low-resource settings, with a focus on affordable and rapid tests that can be deployed at the point of care. Tests like lateral flow assays, which detect fungal antigens or antibodies in bodily fluids, have shown promise in detecting pathogens like Cryptococcus with precision. However, access to these tests remains limited in regions where they are needed most, such as Africa and Latin America. To combat the silent spread of fungal diseases, initiatives like the Global Action Fund for Fungal Infections, GAFFI, are advocating for the development and adoption of cost-effective diagnostic tools. These efforts are essential in saving lives and preventing the rise of antimicrobial resistance due to inappropriate treatments. While challenges persist, the push for wider access to fungal disease diagnostics is gaining momentum. Researchers and organizations are working tirelessly to bring these critical tests to underserved populations, aiming to break the cycle of neglect and improve healthcare outcomes globally. Source: Nature. Next story. Discover the dangers. Over 4,000 hazardous plastic chemicals uncovered in recent report. In a groundbreaking report released on the 14th of March, a team of scientists funded by the Norwegian Research Council unveiled a shocking discovery. More than 4,000 plastic chemicals are deemed hazardous. This exhaustive study, conducted over a year, resulted in the compilation of over 16,000 plastic chemicals, with a significant portion marked as persistent, bioaccumulative, mobile, and/or toxic. Lead author Martin Wagner, an environmental toxicologist at the Norwegian University of Science and Technology, expressed astonishment at the sheer magnitude of hazardous plastic chemicals identified. The lack of available hazard data for over 10,000 chemicals, coupled with the absence of publicly accessible information on their specific uses in plastics, poses a significant challenge. The timing of this report aligns with upcoming United Nations treaty negotiations on global plastic pollution, urging regulatory measures for chemicals leaching into the environment. Highlighting the urgency, the report suggests that over 3,600 concerning chemicals are not currently regulated by global efforts, emphasizing the need for immediate action. Despite the alarming findings, industry transparency remains a pivotal concern, with the Plastics Industry Association and the American Chemistry Council advocating for a balanced perspective on the benefits of plastic additives. The report's insistence on prioritizing hazard assessment over risk evaluation underscores the necessity for stringent regulations to mitigate environmental and health risks. The comprehensive database categorizes hazardous chemicals into 15 groups for targeted intervention, focusing on compounds like pH phthalates and bisphenols. Emphasizing the critical need for transparency in disclosing chemical compositions, the report advocates for a collaborative effort to address existing knowledge gaps and safeguard human health and the environment. As the debate over the Global Plastics Treaty rages on, the report serves as a clarion call for policymakers to heed scientific evidence and take decisive action. With the fate of the treaty hanging in the balance, governments are urged to overcome stalemates and implement stringent regulations to combat the pervasive threat posed by hazardous plastic chemicals. The quest for a safer, more sustainable future hinges on transformative policy decisions and industry accountability. As researchers delve deeper into the complexities of plastic pollution, the collective effort to address the hazards of plastic chemicals stands as a beacon of hope amidst the environmental challenges we face. Source: Nature. Next story. Optimizing cryo-EM with square or rectangular beams for enhanced performance. In the realm of cutting-edge cryogenic electron microscopy, cryo-EM, a groundbreaking innovation has recently taken the scientific community by storm. Imagine a world where the mysteries of cellular landscapes and macromolecules are unraveled at unprecedented resolutions and speeds, providing profound insights into the intricate workings of biological processes. This is made possible by the fusion of fringe-free illumination and aberration-free image shifts, creating a perfect storm for advancing single-particle analysis, SPA, and cryo-electron tomography, cryo-A. However, a significant hurdle has long plagued automated cryo-EM data collection: the mismatch between the circular electron beam profile and the square or rectangular camera dimensions. This disconnect leads to a loss of over 36% of the exposed area during imaging, hindering the full potential of data acquisition. But fear not, as in a recent edition of Nature Methods, two groundbreaking studies have introduced a game-changing solution: the utilization of square or rectangular beams to harmonize with the camera's dimensions, revolutionizing data acquisition efficiency in both SPA and cryo-ET studies. Enter Brown et al. And Chua et al., the trailblazers behind this innovative approach. Brown et al. Etched square and rectangular apertures of various sizes and orientations onto a silicon wafer, ensuring that the beam aligns closely with the camera without the need for lens modifications. Meanwhile, Chua et al. Installed aperture plates with square holes on the C2 aperture rod, adjusting the beam's rotation by fine-tuning the P2 lens strength. The results were nothing short of astounding. The use of square or rectangular beams increased the acquisition area by over 70%, with resolutions matching those obtained with conventional round beams. Furthermore, the novel aperture designs showcased minimal aberrations and maintained image quality, opening the door to capturing a broader range of biological samples with exceptional detail. But the innovation didn't stop there. Chua et al. Elevated the impact of square beams by applying them to cryo-ET, presenting a novel acquisition scheme that minimized overexposure in adjoining areas during montage cryo-A. By decoupling beam image shift from sample tilt, their method ensured seamless tiling in large datasets, propelling the field of cryo-ET to new heights. As we stand on the cusp of a new era in cryo-EM, the future looks brighter than ever. With square and rectangular beams paving the way for enhanced data acquisition efficiency and image quality, the possibilities are limitless. Imagine the secrets waiting to be unveiled, the boundaries waiting to be pushed. The world of cryo-EM stands on the brink of a revolution, and it all started with a simple yet ingenious idea: changing the shape of the beam. So, buckle up and get ready to witness the extraordinary unfold before your eyes as cryo-EM's multi-shot potential is unleashed by square and rectangular beams, propelling us into a realm of discovery like never before. Source: Nature. Next story. Uncovering the intricate dance of NLRP3 and ASC with CD63 on mast cell granules. In a stunning revelation, a recent study published in Nature Immunology has uncovered a mesmerizing dance between NLRP3 and ASC proteins with CD63 on mast cell granules, shedding light on a novel mechanism underlying allergic responses and anaphylaxis. Granulosomes, hitherto unseen structures, were discovered to form on mast cell granules when NLRP3, ASC, and CD63 come together in a unique partnership. These granulosomes facilitate the transportation of mast cell granules to the cell membrane for degranulation, a pivotal step in allergic reactions. The study delves into the role of NLRP3 and ASC in mast cell degranulation, a process crucial in eliciting allergic symptoms. The researchers found that these proteins were vital for the release of inflammatory mediators, such as histamine and leukotrienes, in response to allergens. A fascinating discovery emerged as researchers explored the regulatory signals involved in granulosome formation. NEK7 and PYK2 kinases were found to play essential roles in stimulating NLRP3 and ASC deposition on mast cell granules, leading to the formation of granulosomes. These complexes, composed of NLRP3, ASC, and CD63, orchestrate the movement of mast cell granules to the cell surface for degranulation in response to allergens. Moreover, the study uncovered the involvement of dynein, a motor protein, in shuttling granules along microtubules during degranulation. NLRP3's unique interaction with dynein was found to be crucial for directing mast cell granules towards the plasma membrane, facilitating degranulation. Remarkably, the researchers demonstrated that targeting NLRP3 with a small molecule inhibitor called CY09 effectively impeded mast cell degranulation, presenting a potential therapeutic avenue for allergic reactions. This groundbreaking study not only unravels the intricate cellular choreography underlying mast cell degranulation but also paves the way for developing novel therapeutic strategies for anaphylactic responses. The findings offer promising insights into the potential use of NLRP3 and IL-1 beta inhibitors as therapeutic agents in mitigating allergic reactions. The intricate pas de deux between NLRP3, ASC, and CD63 on mast cell granules opens up a new realm of possibilities in understanding and managing allergic responses. As this research unfolds, it holds the promise of revolutionizing the treatment landscape for allergic disorders. Source: Nature Immunology, Nature. Next story. Revolutionizing chemistry, harnessing single-molecule technology with advanced robotics. In the world of cutting-edge research, a groundbreaking development has emerged: the fusion of artificial intelligence and single-molecule chemistry. Imagine a smart robot, equipped with the ability to synthesize single molecules using the tip of a scanning probe microscope, all guided by the intricate algorithms of AI. This visionary approach not only automates the synthesis process but also delves deep into extracting valuable chemical information from these reactions at an atomic scale. Picture a scenario where molecular structures are meticulously manipulated and analyzed, paving the way for unparalleled advancements in nanotechnology and materials science. The implications of this amalgamation are profound. It opens up a realm of possibilities in atomic-scale manufacturing, where precision and efficiency are paramount. By harnessing the power of AI, researchers can delve into the realm of single-molecule chemistry with unparalleled control and insight, pushing the boundaries of what was once deemed impossible. The study, conducted by Zeelan Ruan and J. Michael Gottfried, showcases the immense potential of this innovative approach. Their work exemplifies the marriage of AI and chemistry, highlighting the transformative impact it can have on various fields, from magnetic materials to synthesis and processing techniques. This groundbreaking research not only sheds light on the capabilities of AI but also underscores the importance of interdisciplinary collaboration in driving scientific progress. It blurs the lines between traditional disciplines, paving the way for a future where innovation knows no bounds. As we stand on the cusp of a new era in scientific exploration, the marriage of AI and single-molecule chemistry serves as a beacon of hope, guiding us towards uncharted territories of discovery and innovation. The possibilities are endless, and the potential for transformation is boundless. In a world where technology continues to reshape our understanding of the universe, this fusion of artificial intelligence and chemistry stands as a testament to human ingenuity and the relentless pursuit of knowledge. It is a glimpse into a future where the impossible becomes possible, and where innovation knows no limits. Through the lens of this groundbreaking research, we catch a glimpse of a world where smart robots and AI redefine the very fabric of scientific exploration, propelling us towards a future limited only by the boundaries of our imagination. Source: Nature. Next story. Unpacking the role of social capital in encouraging consumer involvement in food safety governance. Insights from Chinese online consumers. In the realm of food safety governance, the role of consumers has been the focal point of many discussions. The dilemma of collective action often hinders consumer participation in ensuring food safety standards. However, a recent study conducted in China sheds light on how social capital can pave the way for enhanced consumer involvement in food safety governance. The study collected data from 1229 online food consumers in China, focusing on the effects of social capital on consumer participation in food safety governance. Through advanced regression models, it was revealed that social capital plays a vital role in mitigating the negative impact of free-riding behavior, thereby encouraging consumers to actively engage in food safety governance initiatives. The research highlighted that social capital operates through two main pathways: by promoting the sharing of crucial food safety information among consumers and by facilitating the direct supply of safe food. These findings suggest that social capital acts as a catalyst, fostering a sense of trust, reciprocity, and cooperation among consumers, thus enhancing their participation in ensuring food safety standards. Furthermore, the study explored various participation modes adopted by consumers, ranging from traditional complaint filing to information sharing and direct supply of safe food. The results indicated that social capital significantly influences consumers' propensity to select participation modes that involve information sharing and safe food supply, indicating a shift towards more integrated and comprehensive approaches to food safety governance. The implications of this research resonate beyond the confines of China's food safety landscape. The findings suggest that social capital can be leveraged to address the collective action dilemma, promoting consumer participation in food safety governance globally. By fostering trust, reciprocity, and community cohesion, policymakers can harness the power of social capital to facilitate information sharing, enhance consumer engagement, and improve food safety governance practices. As the world grapples with evolving challenges in food safety, the insights from this study underscore the pivotal role of social capital in empowering consumers to actively contribute to ensuring the quality and safety of food products. By fostering collaborative relationships and leveraging social networks, stakeholders can work together to build a more resilient and effective food safety governance framework. This research not only sheds light on the significance of social capital in promoting consumer participation in food safety governance but also offers valuable insights for policymakers and stakeholders seeking to enhance food safety standards on a global scale. Source: Nature. Next story. Unlocking ESG decoupling through corporate digital transformation. Insights from China. In a dynamic business landscape where technology continuously shapes the way companies operate, a recent study has shed light on the impact of corporate digital transformation on the alignment of environmental, social, and governance (ESG) practices with actual performance. The research, which focused on Chinese A-share listed firms from 2010 to 2019, explored how digital transformation influences ESG decoupling, where there is a mismatch between what companies report in ESG disclosures and their actual actions. By utilizing text analysis methods, the study found a significant connection between corporate digital transformation and the reduction of ESG decoupling. The analysis indicated that digital transformation enhances a firm's information processing ability, thereby improving the accuracy and reliability of ESG reporting. Moreover, it was revealed that digital transformation helps in reducing information asymmetry, making ESG disclosures more consistent with actual activities. The implications of the research are substantial. It suggests that corporate digital transformation plays a crucial governance role in addressing ESG decoupling issues. Furthermore, the study highlighted the economic consequences of digital transformation by indicating that it can promote high-quality development within companies by reducing ESG decoupling. The results of the study emphasize the importance of leveraging digital technologies to enhance ESG reporting quality and transparency. The findings could guide policymakers to adopt measures that support digital transformation initiatives, especially in regions that are lagging technologically. Moreover, the research underscores the significance of companies aligning their digital strategies with ESG goals to drive sustainable and responsible business practices. By uncovering the interplay between digital transformation and ESG decoupling, the study contributes valuable insights to the evolving landscape of corporate sustainability and technology integration. As the digital economy continues to shape business operations globally, understanding the impact of digital transformation on ESG practices becomes increasingly vital for organizations striving for long-term success and stakeholder trust. Source: Nature. Next story. Unlocking worldwide dengue case counts, a comprehensive public dataset. In a groundbreaking effort, the Open Dengue database has compiled a vast collection of publicly available dengue case count data from 102 countries spanning nearly a century, making it the most comprehensive dataset of its kind. With over 56 million cases meticulously documented and standardized, the database provides a valuable resource for researchers and public health officials. The dataset, available in various resolutions, allows for in-depth analysis of dengue transmission, disease burden estimation, intervention targeting, and future projections. Dengue, a global health concern transmitted by Aedes mosquitoes, poses a significant threat to populations worldwide. The expansion of environmental suitability for dengue transmission due to factors like climate change and urbanization is projected to increase the at-risk population in the coming decades. The challenging task of collecting consistent and comparable dengue incidence data has led to the creation of Open Dengue, bridging the gap by aggregating data from various sources in a standardized format. Previous attempts at creating global dengue databases have faced limitations in terms of coverage, timeliness, and data consistency. Open Dengue aims to address these shortcomings by leveraging digital data collection systems and the lessons learned from the COVID-19 pandemic in making infectious disease data publicly accessible. By providing high spatial and temporal resolution data in a machine-readable format, Open Dengue sets a new standard for dengue surveillance and research. The dataset undergoes rigorous validation processes, including data processing, error checking, and source documentation, ensuring the reliability and accuracy of the information. Users can choose from 3 data extracts based on their research needs, whether focusing on national estimates, spatial analysis, or temporal trends. These extracts offer flexibility and granularity, catering to a wide range of analytical purposes. Continuous development and version updates of the Open Dengue database are planned to enhance data completeness and resolution further. Contributions from users to fill data gaps and provide feedback are encouraged, fostering collaboration and improving the dataset's quality over time. Researchers and public health officials interested in dengue dynamics, trends, and interventions can leverage the Open Dengue dataset to gain valuable insights and inform evidence-based decision-making. For more information, visit Scientific Data, a global dataset of publicly available dengue case count data, Nature. Next story. Unlocking the Power of Genomics in Healthcare. In a groundbreaking study titled Genomes in Clinical Care, researchers from the University of Tübingen in Germany, in collaboration with Illumina, Inc., have demonstrated the transformative potential of genome sequencing in clinical diagnostics. The study, published in NPJ Genomic Medicine, showcases the successful application of short-read genome sequencing, SRGS, as a first-line routine diagnostic tool for various medical conditions, including developmental delay, intellectual disability, childhood solid tumors, and degenerative eye diseases. The research team focused on addressing key pillars critical to the implementation of genome sequencing in clinical care, such as bridging the gap between theory and practice, preparing clinicians and laboratories for integrating genome sequencing, and effectively implementing and scaling genomic testing in a diagnostic lab. By developing robust clinical care networks and workflows accredited by Germany's national accreditation body, the researchers laid the foundation for the comprehensive analysis of genomic data in a clinical setting. The study also delves into the complexities of analyzing secondary findings, actionable genes, and polygenic risk scores, providing insights into the potential implications for disease prevention and treatment decisions. Moreover, the researchers explored the integration of long-read sequencing technologies and other omics data to enhance diagnostic sensitivity and precision in genomic analysis. Through their innovative approach and meticulous attention to detail, the research team has set a new standard for personalized genomic medicine, offering patients and clinicians a wealth of information to inform medical management and improve patient outcomes. The study underscores the importance of integrating genomic data into clinical care pathways, paving the way for a future where genomics plays a central role in precision medicine. This groundbreaking research represents a major step forward in the field of genomic medicine, showcasing the immense potential of genome sequencing in revolutionizing healthcare and personalized medicine. The study's findings will undoubtedly shape the future of clinical diagnostics, offering new insights and opportunities to improve patient care and outcomes. Source: Nature. Next story: testing the effectiveness of behavioral science strategies in boosting vaccination rates. In the realm of behavioral science, a groundbreaking study has shed light on the transferability of various behavioral insights to field settings. The study, led by a team of researchers investigating the promotion of COVID-19 booster uptake, delved into the effectiveness of different interventions across 3 randomized controlled trials, RCTs, involving a massive cohort of over 300,000 individuals. The trials focused on text-based interventions targeting booster vaccination uptake, drawing from diverse sources of behavioral science knowledge. Interventions were evaluated based on prior field experiments, online study results, and expert opinion forecasts. The research aimed to ascertain which strategies were most effective in real-world scenarios, particularly in encouraging individuals to receive their COVID-19 bivalent boosters. Despite prior exposure to COVID-19 vaccination messaging, reminders and language emphasizing psychological ownership were found to significantly increase booster uptake. However, interventions based on predicted effectiveness or hypothetical studies, such as bundling COVID-19 boosters with flu shots or addressing misconceptions, did not yield substantial benefits over simple reminders. The study's findings underscore the importance of testing interventions' transferability to real-world settings, highlighting the complexities of behavioral science application in practical contexts. The research not only provides valuable insights into boosting vaccination rates during the ongoing pandemic but also contributes to building a robust foundation for behavioral interventions in addressing critical health challenges. This groundbreaking study adds a significant nuance to the field of behavioral science, emphasizing the need for rigorous assessments of intervention effectiveness and the importance of bridging the gap between theoretical insights and real-world applications. Source: Nature.